Okay. So I've compiled a PDF of problems suggested by people. Can you all see the PDF?
Yeah. Also, can you share that in the announcement channel if people want
Yeah,
to see the question?
I'll send it. Okay, it's been sent. And yeah, there are a lot of problems, 16 of them. So you all can choose which of these we'll do first. Once you've gone through the problems and decided what looks nice, just type in the chat what you'd like them to do. I'll also keep scrolling through these. Someone doesn't have Discord right. Which problem are you talking about, the by?
Can we do problem 2?
Yeah.
Okay,
If
2 and
anyone else agrees with you also. Otherwise, someone said 12 too.
what is 12?
This.
Oh, the China TS. Okay, we can do 12 then. 2 votes.
Just like 15 people. We'll just wait to see if anyone else has any recommendations. Your votes vote. Also, people switch on your videos. It's unless you have some situation with your webcam. We'll just wait for another minute in case. Okay, I guess we can just begin with problem 2, as people seem to want to do that. Yeah. So that for every row. Okay. So you can pick any row, and for every pair of 2 columns that's there exists some other row that has whatever is here. If this is 1, 2, 3, 4, blah, blah, this is also 1, 2, 3, 4, and so on. Except it differs in this place only. And everywhere else, it is the same. I don't know the sources. It's possible this is old Russian. Okay. So how would we do this? And also people preferably speak rather than saying stuff in the chat. Mm. So if you fix any row, you know that you can pick, there's 10 columns here, and we have n rows. So really to choose 2 columns, you have 10 choose 2, which equals 45 ways. But we do need to show n is at least 512. So in some sense, we want half of all the possible binary strings in some sense, which is interesting. The same digit to permutation? No, it has like the exact same digit in each column, except for those 2 columns. Okay, also some obvious optimizations that we can make. We can probably just assume that we always write only zeros and ones, for example. Can we assume that? Um, Maybe not, but I imagine the equality case will only require 2 numbers. Hmm. If anyone has any ideas, feel free to suggest stuff. There's no real point if all that's going to happen is me speak. Okay. Like, here is one idea. Let's just fix a row. And for every other row that's there, let's just keep track of what all columns that it differs from this row. Let's call this capital R, and this some row R1, R2, so on. And we have it all the way until Rn minus 1. So we know that everything, let's actually, to every pair of the form R comma Ri, we'll just assign some sort of tuple where the ith digit of this tuple is 0 if they're the same in that spot, and 1 if they're different. So we know that for every pair of ones that you can have, there will be some tuple that satisfies this sort of thing. But additionally, we also know that if you want to try and compare Ri and Rj,
How are you writing the 2 parts?
if this if this is the second digit, so this is 1 if the digits are different.
Okay.
And 0 if they're the same. The problem doesn't say anything. Or digit. Sure, that's all. So okay, 100 is pretty big. Let's just look at a smaller case, say when we have 100 replaced with a 2. 2 may be too small, but we'll figure it out. Okay. In the case of 2, clearly you will need 2 rows because one row, let's say it has 1 and 2, and you need another row that differs in it in exactly these 2 columns. So let's say 3 and 4. And this is a construction for 2. So maybe in general, the answer would be 2 to the n minus 1. So in the case of 2, it's 2 to the 2 minus 1, which is 2. How about 3? If we have, let's say, something of this form, then to differ in these 2 columns, you would need one row. Then to differ in these 2 columns, you would need another. Then to differ in the first and third column, also you would need another row. So in this case, it kind of works out that you will need at least 4 rows, 1 for just any row you pick, and 3 for all the possible pairs of columns you could pick. But clearly, this sort of thing will not work in general. So
Maybe we
let's
can try to show for 3 case that like find a construction such that all the rows satisfy the criteria, right? And then also we have only 4 rows.
You're saying we can try and prove 4 is optimal?
Yeah, like that would maybe help in finding the construction.
Huh. Do we need to find a construction though?
But we don't need, but maybe like that helps in.
Okay. I think something like this. Yeah. This works. But it doesn't. Yeah. Okay, so onto the case when we have 4 columns. Okay, we can clearly assume that the first row is all zeros at least, because in the column, you only care whether it's same or different. So it can't really matter what digit you pick in each column to begin with. Please don't annotate the screen. So we might as well assume that the numbers are going to be used 0, 1, 2, 3, 4, and so on in some order. So clearly you need these sort of rows. And this sort of thing. Yeah. 2, 3, this is 7. And we would like to show at least 8 as needed. So clearly there is going to be some sort of problem if we try and check if this works. Mm.
In 0011, the last row, if you pick the first 2 columns, then there should be a row with 1, 1, right? But there
Yeah.
isn't.
Okay, this one differs in 4 places, not 2. You're right. Also, in general, I see the construction. You can just pick all binary strings with an even number of ones. And that works because for any 2 binary strings that you pick, if you flip over exactly any 2 digits, the parity of the number of ones is going to stay the same. So for example, 1, 1, 0, 0, 1, 1, this has 4 ones. And if I just pick any 2 columns and flip over, I'm going to be left with 1, 0, 1, 1, 1, 1. This is a 0. So in general, also this sort of thing will achieve 2 to the n minus 1. So we can be fairly sure that 2 to the n minus 1 is probably the bound in general. But how do we prove it? And I'm not convinced that in general we can just claim that it suffices to use just zeros and ones, because it is possible using more digits has some advantage. Right. So to extend this construction to work, we can add 1100 as Pranav said. Oh, sorry, 111. And again, if anyone has any idea, even if it sounds silly or anything of the sort, please do tell.
Okay, I was thinking of making a graph, like represent each row by a vertex, and you connect two vertices if they have like different exactly two places.
Yeah, that makes sense. That's also a very reasonable thing to do.
But I
If
don't
we
know what
just,
do you exactly want to do with the graph.
yeah, that is true. You essentially know that every graph, I mean, every vertex has degree at least 45,
Yeah.
but that's also a bit weird.
And you need to show that there are at least 512 vertices, basically.
Mhm. Yeah. Okay, I
This
think
feels like
the
some
simplest,
standard double counting type of thing, right? Like
but how?
you
Like the
count some,
condition that they differ in exactly two is kind of weird to you.
yeah, exactly to is kind of weird.
Oh, of course, we can just claim, yeah. Okay, fine. So let's fix any row. Suppose the first one, we're calling this R, right? And we'll use the tuple notation as above. Where was this? Here. Yeah. So we know that you can represent everything in this form, every row. Obviously, some rows can overlap in their tuple thing, but that's completely fine. So the claim is that obviously the first row itself can be denoted by all zeros. But we claim that the number of tuples is going to be at least 512, which will imply there are at least those many rows. And so we'll, to that end, we'll claim that every tuple with an even number of ones is present. So for example, let's take the example when you have, what is it, 5 rows, 5 columns, sorry. In that case, it's 0, 0, 0, 0, 0. I'll calculate the
Wait,
stuff.
so like when you have one row as zero, all zeros, then
Mhm.
you are obviously done, right?
Why is that?
Like you can basically show manually that you can achieve at least 512 rows.
Like this zeros, the row itself satisfies zeros, no? Because it differs from itself in exactly 0 places.
Yeah. So now like pick any two pick any two numbers and then you flip. So basically you are having two ones now,
Mhm.
right? So
And then flip
exactly
two
two
more,
ones.
so you get four ones.
Yeah, exactly. But also note that you can't flip ones into zeros because something different to a different number needn't be the same. You could have like 1, 2, and 3, for example. But the point is you can always flip zeros into ones because anything different from the same number will have to be different. So suppose we just want to prove that something of this form exists in our sequence. This has an even number of ones, for example. So by the problem statement, we know that there is a row that differs in exactly these positions. So we know that 1, 0, 1, 0, 0 exists. And again, we know that there is a row that differs from this new row in exactly these two positions. And that row must be exactly this 1, 0, 1, 1, 1.
Also,
So this
Pranav,
way,
what are you
every
saying? Like,
Hmm?
we can assume that there is 0, 0, 0, right? Because, like, you can obviously
Yes,
switch
yes.
any 1 to a 0 in the first thing, and it's like a
Yeah.
bijection.
Yeah, but also it's not only zeros and ones, you're allowed any digits. Like this tuple sort of thing is just you fix a row R, and for any other row, you just, or even the same row, you write this as the tuple
Yeah,
and the set of places where it differs from. Yeah. And so every binary string with an even number of ones exists. And the number of such binary strings is 2 to the n minus 1 in general. To prove it, you could just like fix the first n minus 1 places. And then the last one will be either exactly 0 or 1, depending on the number of ones you have in the first n minus 1. So that's exactly 2 to the n minus 1 of these. And it in fact achieves equality also. So yeah, the problem is true and the bound is stacked. Does anyone have any questions about that proof? I'll assume not, and we'll continue, yes. And again, I'll say this, there is nothing wrong in saying you didn't understand anything. Like, even if you didn't even understand the problem, that's completely fine. It is not an easy problem. But okay, looks like no one has any questions. We'll move on. Does anyone have any suggestions on what we would do next? 11, okay. 11 is the geo. I'll wait for a bit while everyone chooses what they want. 11, 13, and 15. I'm 17, so there's no problem with my age. Okay, someone else says 11. So, okay, unless there's any more votes, we will probably do 11. Okay, even more people say 11. So that is what we will do. I agree 13 looks amazing. We can do it next. We are only half an hour in. I'm sure they'll be. Okay, so a geo. Right, so we have triangle ABC. And we have its foot of altitude to be D. And we draw the circles with diameter AB and diameter AC. Because of the right angle, they both pass through D, as well as the other feet of altitudes. And now we draw these tangents, and suppose they intersect at K and L. Okay. This is K and this is L, I think. So point S is some sort of mysterious point that satisfies some nice angle condition. And it supposedly lies on this circle, which is interesting. So we want ABS to equal 180 minus B and ACS to equal 180 minus C. Okay. Yes, we can do like this. Although in that case, we would kind of lose symmetry if we took only one angle condition. So I was thinking maybe we could assume it satisfies both angle conditions and then show it lies in circle AKR. Although, yeah, both of them are technically equivalent and should work. So ABS being 180 minus.
Oh,
What
Okay,
is
this
this?
is like a very big guess, but maybe S is the point BL cap CK.
BL cap CK. That would be very nice. Actually, that's a very reasonable guess. Let's
Hey,
just
this is just the
consider.
reflection of A in the midpoint of BC, no? Because
What is
AB is
parallelogram?
parallelogram.
Ah,
Wait,
wait, but
is
no,
it?
no,
No,
it's not.
sorry, that's not true. That is okay.
Also, our reflection seems nice because of the angle condition.
I
Except I
agree. The
couldn't.
reflection does look
Yeah.
interesting. Okay, let's just look at what angles we get. So I need new colored green. So because of the tangency, we have this equals this. That's angle C and ABL. Yes. So indeed, ABS is 180 minus angle C. Wait, that's the wrong angle conditions.
Ah, yeah.
That's unfortunate.
Yeah.
No, okay. All hope is not lost. Maybe let's call this X. I feel like maybe BCX gap stuff. Like BCKL's
Oh,
Mikhail
yeah.
point, it might be point S. So let's imagine its Mikhail point is this. Then what do we know? We know that angle SBC then equals angle SLQ. And the angles don't seem too nice. Yes, let's do. But yeah, I do like point X. It seems fairly useful.
Also, like if you look at the quadrilaterals ABXC and ACSB, then the angles are equal.
ABXC and ACSB. I see.
And even the two
Is it
sides are.
just like the reflection of X across the perpendicular bisector or something then?
Yeah, it looks like that.
Okay, it probably has to be.
Is it true though?
Sorry?
Is it true though?
Is it true though? Only one way to find out. Like, according to the angle conditions, yes, S must be the reflection of. Let's just write it down. Or if we could just write BCXS is an isosceles trapezoid. Whether S lies on XBC or S lies on ALK, that we do not know yet. But we will find out. Okay, how about these other angles? What does like this equals this? And that is angle B.
Wait, but then BCX is like isosceles, right? Because XBC and XCB are both angle A.
XBC is angle A. Oh, you're right. Oh, so X equals S. What?
Yes, that is why we cannot.
Oh, but that looked like the wrong angle. Okay. You're right, yeah. XB does equal XC because this is angle CB. So this is it. And okay, so X is just points such that XB and XC are tangent to the circumcircle of triangle ABC. But yeah, it does mean that S is not what we thought it was.
Well, but like BC access is isosceles trapezoid, that's still true, right?
It can't really be true because BX equals
should be
CX. So unless S equals X, that's not possible. So okay, let's remove this stuff. Okay, so we do know that angle ACS is 180 minus C, and we know ACX is 180 minus B. Which of these is greater? ACS is greater. Okay, S shouldn't even be here probably. No, it's actually, what is it? Also, XA is diameter of the circle. Oh, that's the eraser. We have stuff.
Yeah, so S is the isogonal conjugate of reflection of A and BC. That is the condition.
Yes.
So S must
Yeah.
lie on the what? Circumcenter CVN.
Circumcenter CVN?
Because it's the isogonal
Yeah.
conjugate of
Okay.
reflection of A and BC. No.
So okay, S is definitely not here. I'll just erase this stuff. Or maybe this is just a bad diagram. Let's just look
A reflection of A and BC.
like if that was A dash, then it's isogonal.
No, X is intersection of tangents. A dash is reflection.
Yeah, A dash is the reflection. This is S, no? Oh, isogonal conjugate you meant of X?
I meant A dash. I was replying to Arav.
Ah, okay.
So
Yeah, so S.
yes.
So yeah, this
How is
also I
that
think this
evident?
should just mean S lies on BCX. Okay, that's probably a more direct way. 180 minus B, 180 minus C.
AB that should be like 2B, right? So how is this like isogonal conjugate of that?
Sorry?
AB dash is like 2C, right? Sorry, 2B.
AB A dash is 2B.
So
Yes.
if S is isogonal conjugate, then ACS should be 2C, 2B, sorry. But ACS is 180 minus C.
Is that how isogonal conjugate works? No, it should be like AB A dash equals SAB or something.
Oh,
And in this case, it doesn't.
Yeah, it's this is 2B and this is 180 minus 2B. So it depends on how you measure, right?
Yeah.
Because the directed angles matter.
No, but even then, like this is B, this 2B or 180 minus 2B. That's A dash BA. So the isogonal conjugate should equal that of SBC, which is 180 minus 2B, right? Yeah. Okay. So we do know that it goes through the circumcenter, which lies here somewhere. Let's remove this fake circle.
Yeah, actually, I think it also lies on BOC because the isogonal conjugate of circle BHC is circle.
Oh yeah. It lies on BCXS. I mean, that's cyclic.
Yeah.
Because uncle is there. Okay, so this is in fact true. Okay, that's interesting.
Also, that's the root BC inverse of the orthocenter. So maybe you could try inverting.
Ah, that's true. Wait, we just want to show S is the Mickel point of BCKL. That is actually true, although the diagram is off.
It's
Because
true,
S
right?
is
Because
supposed
KAC is KDC, which is 90 minus B, and SAC is also 90 minus B. So we get SAK is 180 minus 2B, which is SBC.
Wait, how are you finding SA? Okay, oh, this angle, this. How do you find this angle? B90 minus B90 minus B. And this is what,
SAC is
2B90,
also 90 minus
180 minus 2B.
which is SBC.
Ah, wait, that's not equal to S. It is. So SAK equals SBC. Why does that finish?
Like S is like center of spiral similarity, which maps BC to LK. So you get
Okay.
like circles made.
Okay, yes, that does.
Wait, can you repeat the finish which Kanak said?
Angle SAK is angle SAC plus CAK.
Hmm.
SAC is OAC 90 minus B.
Yeah.
And CAK equals CDK 90 minus ADK, which is 90 minus B.
Yeah.
So SAK is 180 minus 2B.
Yeah.
And that equals angle SBC, which is also 180 minus 2B.
How do you find SBC? Okay, yeah, you can find it.
ABS is given to
Yeah,
be
yeah.
180 minus B, so you subtract the B.
Hmm.
So this means that S is the spiral sim center.
How is this balance?
Like, for
Oh,
example,
SBC equal to SLK, so BC goes to LK.
yeah. Okay, technically we should redefine S so that it lies on the circle and satisfies one angle condition, but yeah, the same thing. Okay, that's a nice problem. Does anyone have any questions on the solution? Okay, I'll resume now. And what was the source of the problem? I don't know. We can check Discord and ask the person who sent it, which I thought was Arizona. Yeah. Okay, so which problem do we do next?
You said 13, right?
We are doing 13. Okay. Does anyone have any problems with 13 or we'll do that? Okay. No one has any objections. We will do this. Which does look interesting. Yes. Cannot be written as big stuff. Yeah. Okay, also what? So py plus 1. If it does have such a representation with a greater than y and b greater than y, then clearly this is greater than y square. So this means like b is greater than y, which means nothing. Okay. Fine. But it also does somewhat mean that since y is around p by 2, we should expect like this value ab by y square to be around 2 or less than 2. So a and b are greater than y, but they're not too much greater than y. Okay. This is from AR. Makes sense. Russia has nice problems. Okay, so can they both be greater than 2, 5. For example. Yes, that's possible. So one thing we do know is that obviously P will not, yeah. So P will not divide A or B because of this equation. And also no value of A will work for two different values of Y. For example, if A divided P Y1 plus 1 and also A divided P Y2 plus 1, then this would imply that A divides P times Y1 minus Y2, which is P times some number that's at most P by 2. And this is greater than Y2. Or actually, we should not do this. Yeah. Because A does not be A is co-prime with P, we can actually just delete the stuff. And this implies that this isn't really possible. So we know that the set of A and B you get each time have to be like completely disjoint, which is also interesting. Hmm. So, okay, if we consider the set, so if we take y equals 1, then we get some certain A1 and B1. If we take y equals 2, let's say you have A2, B2 equals BY plus 1. And so it's interesting. AB are less than P? Yes, okay. Yeah. A and B are both less than P, that is true. Oh, is there also some parity stuff? Okay, we don't know anything about the parity. Okay. Is it possible that this is actually a square number? In which case we don't get two distinct values of A and B. In that case, you would need Py equals A square minus 1, A minus 1 plus 1. Because both A minus 1 and A plus 1 are at least Y. Y can't really contribute to the other factor, so you would require that A minus 1 equals Y and A plus 1 equals P.
But this just fails
But
because of
that's
size.
just bad, yeah. No, because Y is also less than P by 2. So this is not possible. Okay, so this AI and BI can never be equal, but also you can never have any AI equal to a different AI or BI. So the set of, you can do this for Y equal to 1, 2, all the way until Y equals floor of P by 2. And in all of this, you get at least 2 times floor of P by 2, which is what? P minus 1 pairs, P minus 1 distinct numbers. But all of them, as someone observed, are strictly less than P. So the only real possibility is that the set of AI and BI equal the numbers 1, 2, 3, all the way till P minus 1 in some order. So all we would like to do is to eliminate this possibility. Which
I mean,
does,
one is not possible, right? Because
One?
it is strictly greater, not
Yeah,
greater
okay.
than
1 is
equal.
not possible because it's strictly greater. So you have only p minus 2 numbers and you need at least p minus 1, which is bad. Okay, that's a nice problem. Does anyone have any questions about the solution?
Can you explain the finish? Like what set of numbers you're considering?
So for y equals 1, we look at a
Uh.
number p plus 1. This is p plus 1 and this is 2p plus 1. And if we assume the problem is false, then it can be written as the product of a1, b1, where each is greater than y, right?
Yeah.
Similarly, you have a2, b2, and so on.
Yes.
And you have it all the way until a floor p minus 1 by 2, b p minus 1 by 2.
Yeah.
So you have overall p minus 1 distinct numbers because we showed that ai can never equal bi. And also from this, you can't have the same value of a for two different stuff.
Yeah.
Yeah. So they should be p minus 1 distinct numbers, but all of them are strictly less than p also.
Oh, and then you only have p minus 2 choices.
Exactly.
Yeah. Okay. Right.
And one can't work, so you have only p.
Yeah.
Yeah. Okay, that's nice. Does anyone else have any questions? I will assume no. Okay. Let us move on to the next problem. What problem would you people want to do? Also, please don't annotate the screen and remove it. Can you do a walkthrough of which problem? The one we just did, problem 13. Okay, so we'll just go over it one more time. So we're assuming the problem is false. So for all values y equals 1 to all the way till p minus 1 over 2, we have that py plus 1 can be written as ab, where both a and p are greater than y. So some observations we're going to make is that it's never possible for a to equal b, because if it was equal, then this equation becomes py plus 1 equals a square. So this factorizes as py equals a plus 1 times a minus 1. So since p is prime, it's going to divide at most one of these factors. But note that both a plus 1 and a minus 1 are both at least y, because they're both greater than y. So the only possibility that you can have this sort of thing is if a minus 1 equals y, and a plus 1 then has to equal p. But this would imply that y equals p minus 2, which cannot happen. Actually, maybe it can happen when p equals 3, but we can eliminate this possible case. We can clearly check p equals 3 and 5, for example, to show that this works. So for all primes at least 7, let's say, we know that a will never equal b. And further, we know that the same value of a cannot work for two different values of y. If that's not true, then thank you, Pranav. Okay, so suppose that that's not true, in which case a divides p, let's say y1 plus 1, and also divides p times y2 plus 1. Then it also divides their difference, which is p times y1 minus y2 mod. But of course, p does not divide a, so we can actually just remove p from this divisibility. And it just means a divides y1 minus y2. But we know that a is strictly greater than both y1 and y2. So this divisibility is not possible unless y1 equals y2, which is not possible because we assume they are distinct. So if you consider the value of a and b you get for y equals 1, 2, 3, all the way till p minus 1 over 2, all of these numbers you're going to get are going to be completely distinct from each other. So you're going to have a total of p minus 1 such numbers. But we also know that every such number is strictly less than p. So the only possibility is if it equals 1, 2, 3, all the way till p minus 1. But it has to be strictly greater than y, and y is at least 1. So in all cases, it's greater than 1. It can never equal 1. So you only actually have p minus 2 values, but you need p minus 1, which is impossible. So the problem is true. Does that make sense? Okay. So what problems were people voting for? Someone said 8, 15, 15, 8, 12, 15. 12, 15, 17, 5. Which number is appearing most? Okay. Lots of people seem to want 15, I think.
9.
Yes, okay. 15. Okay, also this time I didn't notice, but next time don't vote twice. Okay. Sequence. Oh, chessboard. Each cycle. Okay, so a cycle is what you would expect it to be. For example, if we take a 3 times 3 chessboard, or let's actually take 4 times 4, so we can actually see 5 times 5. Right? Okay, so for example, this sort of thing would be a cycle. This sort of thing is also a cycle, but you can't really do something like this because all these squares are supposed to be pairwise distinct. So the cycle can't really come back and intersect itself. It needs to be what you would expect, a proper cycle. This looks hard, yeah, but it doesn't look that bad. And we call a subset of these squares mischievous if every square contains at least one square from X. Okay, so for example, coloring like a normal chessboard coloring would ensure that there are no cycles that cannot contain anything from it. Because any square you're on, the next one you go to will form a cycle. Okay. So in some sense, it's just saying that the uncolored squares, they like form a tree or something. For example, we can delete this. We can delete this, even this, even this, no? Yeah. Okay, that's interesting. Because it looks like you don't need too many of this stuff to prevent cycles. Okay, interesting. Maybe this is actually a graph theory problem after all.
Also, can you explain what does this thing, subset X of this chessboard square is mysterious line?
Yeah, so for example, these cells that have colored black, not blue, black. If you consider this to be the subset X, then for any cycle you pick, let's say something that looks like this, it contains a square from X, which has been colored black.
Okay.
That's all that's saying basically. So like if, for example, I remove this, then this would be a valid thing. So this doesn't work.
Yeah.
Yeah, actually, I think this has to be graph theory or something. So we know there's like n square squares, and most of them have degree around 4. Let's just assume we're working with n sufficiently large, so I'll really ignore all of the border squares for now. So we know there's like every vertex has degree approximately 4. So the number of edges should be around 2n squared. And you sort of want to delete a bunch of vertices and as a consequence their edges too, such that among the remaining stuff, the graph is acyclic. So, okay, I think actually this construction is not very good. Oh, I think I can actually delete this also. Yeah. Oh, I'll probably add one here then. Yeah, I want the unconnected things to just form a separate tree. Okay, so let's suppose we colored k squares black. So really you end up deleted approximately 4k edges. But we also know that we deleted exactly k vertices.
Well, what do you mean color delete? Sorry, color k square black.
The mischievous subset, I'm just pretending we're coloring those squares black because that's what I did in this picture. So the set of squares colored black are the mischievous squares, if that makes sense. Okay, so the number of edges now are approximately 2n square minus 4k, and the number of vertices are around n square by k, are exactly n square by k. So if the graph is acyclic, then we know that the number of edges must be at most the number of vertices minus 1. So in this case, we get that 2n square minus 4k is at most n square minus k minus 1. We'll ignore the 1 because it's just a constant. And we're looking for really the value of k by n square. So 3k at least n square. And yeah, okay. This implies that k needs to be at least n square by 3, approximately.
So she should be 1 by 3.
Can we color like all squares where sum of x and y coordinate are 1 mod 3?
1 mod 3.
Yes, for example, if we have this board only, then
Yeah,
we
yeah.
color
Yeah, even then also this 1 by 3 thing works, right? Like c equals to 1 by 3.
Yeah.
like the top right.
But also I saw a
triangle.
simpler construction, like in general, just color this and this. And in general also. Or is that coloring too much? It's coloring too much, yeah. Okay, let's look at your 1 mod 3 idea. This is 1 mod 3. This is 1 mod 3.
What?
This is 1. I mean, I'm assuming this is 1 comma 1. I should have probably taken 0, 0. Okay, let's
Yeah.
take 0. Then we have this and this. 3, 3.
What about the center square?
The central 2. That verb.
But
Okay,
then
really, you're
your-
just coloring diagonals. Okay. That's an easier way to think
also
about
your
it.
construction did better, right? Like this does 9 squares, yours did 8 squares.
No, I mean, that's only because I picked this case. I was
Wait, what?
getting around n square by 2 colored. It just happened in this. It's like n square minus n by 2. So for large enough n, this construction is better. Yeah. So like for this square, our construction is 3, 4, 5, 6, 7. As Arif said, we can just color like this stuff. Leave 2, color this. Color this. To color this. Something like this. So basically, these squares are the ones we are going to color.
The source is 2017 Polish Math Olympiad, by the way.
It's a nice problem. And so yeah, so with at most cn square, I assume it will be c at most 1 by 3 or c less than 1 by 3, depending on whether this stuff works out exactly or not. But yeah, that's not
less
the main
equal
part.
probably because
Hmm?
should be less equal only
Huh.
because we're
Oh,
doing
it is
a
at
flow,
most.
right?
Yeah, that's fine. Yeah. each side. Wait, with at most cn square? Oh, yeah, so all c at least 1 by 3. Yeah,
Yeah, correct.
or greater than 1 by 3, one of them. Yeah, that's not the real thing. Okay, how many are you doing? Yeah, you can probably do c at least 1 by 3. Okay, but yeah, this is a nice problem. Point also set for each integer. Does anyone have any questions? We did use graph theory, so I can explain if that wasn't clear. Okay, I take it there are no questions. It is
It's
indeed
really
a good.
interesting that we kind of got lucky because like the construction has a forest, but then we took a tree.
Yeah, it's just OFN thing, so we
Yeah,
can
it
actually
just
ignore it.
goes to
Yeah,
the
because technically for it to work, I was trying to make it have one component, but that's not really needed.
yeah.
But actually you can just like delete a vertex here. Yeah, actually like among every two adjacent diagonals, you can actually delete one edge, one vertex, and it should still be fine. Or okay, I think this is work because it was a corner. In general, no. But yeah, cool problem nevertheless. Thank you, Aaron.
Oh, wait, even in general, I think you can delete, no?
No, like for example, I can't really delete this because it'll form a square here.
Huh.
Okay, what problem will we do next?
Let's do 10.
Someone says 9. Someone says 8. Someone says 12. 12, 9, 16, 9. Okay, lots of 9. Oh god. 9 just looks bad. As not really looks bad, but the fact that you don't have -1 in the domain, it's pretty weird. Like usually you have R plus where 0 is not allowed, but for once you're not allowed
Wait,
-1.
what even happens when you put -1?
Like it's probably like 1 by x plus 1 or something of the sort. Yes, it is SwissMO, which was posted on AOPS a few hours ago. Did we not do this? No, this is problem 5. We did problem 1. Yes, we might as well write. So, okay, also x not equal 0, y. So wait, why is y not equal to x? That's weird. X not equal to 0, I understand. Yes, also to clarify, this is not ISL. The ISL problems would not have been posted in the AOPS.
I think it should be y is not equal to -x because y is equal to -x, then we would have something that is not in the domain of D. Domain of F, I mean.
That is also true.
I see. Oh yeah, it should probably be y not equal to -x. Okay, that makes sense. I need to edit this post on AOPS. But yes, that comes later. So okay, what are the dumbest stuff we can do?
Wait, you posted this problem on the ops?
Yes. So let's look at this. Means f of x times f of 0 plus f of 0 equals x. Wow.
So it's subjective for starters, I guess. Unless
Hmm.
like F0 is 0. No. Even that. No,
I'm
F0
putting
can't be
x.
0 and
Why can't, yeah, f0 is not 0.
So basically like f of f. Oh, okay.
and
F
we
of
get
0
projective
is
because you can like take stuff to the other side.
Yeah, so
Yeah.
we know f of x is just some linear thing in x.
Which means it's subjective.
Oh, that looks bad. Okay, maybe I'll actually add in the constants. because we know it should not take the value -1. So the only possibility is if that linear thing takes the value -1 at x equals -1. This is x minus f of 0 by f of 0. And we know that this must not equal -1. And that can only happen when x equals -1.
Or it would swap -1 and 0 because x equals 0 is not allowed.
Wait, why is x equals 0 not allowed?
Because x was in the
Yes, okay. So it could also be 0. Yeah. So it's possible minus f of 0 is minus f of 0. Or the other
That
possibility.
looks better.
Yeah, I agree that looks better. But, But also we know that f is almost surjective, like apart from possibly 2 points, but from exactly 2 points. And we also know that f of
Don't we get that?
that's actually
Okay,
true.
okay. Yeah, this is fine.
in the triple F trick we could do f of f of. Shouldn't that give a linear relation between x and f of x?
Yeah, we have that
Oh,
f
wait,
of
yeah.
something like cx plus d equals cf of x plus d for some constants. Do we want the constants to be something? They're pretty weird. So, but yeah, okay, this is quite nice.
I mean, you can probably find out F0.
That is true. Except, how do we do that? Okay, let's see what else we can do. This is just one substitution.
Maybe put y equals to minus f square x.
Minus what?
Minus f x.
I see
F.
that. I see that just says that may not be allowed when f of x equals x.
Why?
Because y does not equal minus x.
I would try the
Let-
condition when x is equal to y.
X equals y. Yeah. Okay, first x equals y, then we'll do what you said, Pran. X
Wait,
equal
no,
y.
Pranav
not
thing I
equal to-
think gives a lot. But
It just tells you f of something is x. No?
No, but
X equals y
f
followed
is
by
no,
linear,
it
minus.
right?
gives
So
minus
for
x
at least for
equal x.
infinitely many values of x and y,
Hmm.
so we can just substitute that in. That f of x is equal to cx plus d.
Wait, do we get that?
Yeah, because from your equation, f of cx plus d is equal to something linear in f of x. So
Yeah.
we can, like, from that we can.
Get f of minus f of x. How many brackets is that? 4. This equals x when f of x does not equal x. And you were saying this is useful. Like, oh, this is linear and linear. I see.
No, the equation you wrote over there, f of cx plus d equals cf of x plus d.
Mhm.
That gives f linear, right?
Wait, why does it imply f is linear?
Because like you can compose cx plus d with its inverse linear function to get f of x is equal to that, you know.
But that's like, that'll change the right hand side.
Oh yeah, okay, so the argument is different. Okay.
Yeah.
Right.
But we do know that minus f of x is just minus x plus f of 0 by f of 0. It looks weird, but I'll just write it just in case. F of 0 minus x by f of 0
Wait,
equals.
no, do this with cx plus d, right? So you'll get some equation on c and d because you'll get some linear thing is equal to x, so you get actual values of c and d.
But like, you have to do that 4 times.
2
Which-
times, right? S square of minus cx minus d.
Okay, that's what we're essentially doing.
Okay, okay.
Okay, you're right. So essentially we need this of f of 0 minus x by f of 0 minus f of 0 by f of 0. And have your joke about J problems might actually
And
come
no,
true.
x coefficient is like
But you put yourself in this time.
Yes, yes.
x coefficient is just not going to work out. What?
Okay, so this means that, does this mean f is an involution?
Yeah,
Because this was it
yeah.
was so stupid. Wait, also this was true when x was not -1 and 0. It was true everywhere else. Okay. So we know f
We know
of,
c is 1 and d is 0.
we know what?
C is 1 and d is 0.
I see, yes. And
So
also
we
this is
just
for
get 0
all
value.
x not equal to 0 minus 1. This equals x. So we know f of 0 is 0. So in fact, that involution thing
F
is
0 is
proved.
1 and f of 1 is 0.
Yeah. Okay, so we know f is an involution. Does that help us? Okay, this definitely becomes x plus y. This becomes y. Okay, this might be easier than x plus y times f of y by x plus y equals x.
It
So
also,
f,
did we guess the function?
no,
But okay, we're basically done now, right? Like put x equal 1.
yeah, okay, we need to put y equals something x, zx.
1 minus z upon 1 plus z.
Yeah,
And that's why minus 1 name. So this
yeah. Okay, so f of x equals 1 minus x by 1 plus x. Good. Wow, that is a weird function. And it also explains why -1 is not middle. And f of 0 is 1, f of 1 is 0, and yeah, it is an involution because any function of the form ax plus b by cx plus d with some condition is an involution. It's a weird FE, like I think it is a standard FE with an unexpected solution, but
like it ended up being like much easier than it looks.
yes, I agree.
Like
Like
it was
just
just
the typical
unnecessarily
plug and
looking
chug
complicated,
box.
but yeah.
Hmm. Can you tell how you got the Fy? But what point did you leave at? Like, do you know why F is an involution, or you got after and before that? Okay, it's an involution, so just substitute in this main equation. F of x became x, f of y became y, so you just got this equation. Which why this is some between IOQ problem, maybe. Okay, that's an FE. It's just okay, nothing special, just typical substitution stuff. But it did have an unexpected solution, and I presume the problem was made so that it would be true. But yeah, interesting. All right, what next?
10,
Sorry?
10.
Okay, we have 2 votes for 10, 1 for 12. Another 10. Oh no, that's just Trushell. 12, 16, 12, 8. Okay, looks like 12 is winning. We'll wait for 30 more seconds. Okay, 12 it is. The dreaded China TST problem. Rochelle voting twice does not help you. I can see the names. Okay, so it's not TST. Oh, China MOT or China West one, China Southeast. China. Okay. Anyway. 2n minus 1 is prime. Yes. So if 2n minus 1 is composite, I don't imagine it's too hard to find a counterexample. So let's just try and prove for now that if 2n minus 1 is prime, then you can find something satisfying. Also, I do see that this is tight. If you pick like a1, a2 until an to be just 1, 2, 3 until n, then the maximum value you're going to get of this is n plus n minus 1, which is 2n minus 1. So we can't really prove the problem for anything except 2n minus 1 on the right hand side. So we would be done if P divided AI plus AJ by GCD AI AJ. Maybe that's hoping for too much. Okay, I'll just write this. If we say AI is DI and AJ is DJ, then this equals I plus J. Okay, not too hard. So this is somewhat reasonable. So it would be great if P divided AI plus AJ, but P does not divide AI or AJ. Because in that case, clearly the GCD is not going to be divisible by P. Okay.
Oh, also you can't have P divides AI minus AJ, otherwise the GCD is less than AI minus AJ by P. Okay, unless...
You're saying
Oh,
P can't divide AI minus AJ?
yeah, then the GCD you can bound by AI minus AJ by P.
Oh, I see. Yeah, okay. So if P divides AI...
Unless both AI and AJ are divisible by P, which is a problem.
Yeah, but like you should just be able to, like if P divides everything, just divide out by P.
Yeah, and if P divides something but does not divide something else, then take those two.
But what if P divides some of them and does not divide some? And like among those, you don't have anything.
No,
adding
take
to-
an AI divisible by P and take an AJ not divisible by P.
Yeah,
So, okay, there's an issue, yes.
you would want them to add to multiple. Okay, also, this means this AI
Well
plus.
then like AI over GCD AI AJ is divisible by P, so it's greater than P. If say P divides AI but not AJ.
Of course. Yeah, okay, that's fine. So
Yeah,
if P divides AI,
so
but then P
yeah,
divides
this was the idea in the MBL problem that you
Which
could
MBL?
take the MBL P8 this year.
I haven't looked at the Balkans.
Yeah, but this problem is like really similar.
Okay, so does this just work? You have n, so you need something adding to 0 or subtracting to 0. You can't have all zeros. So worst case, you can have 1 until p minus 1 by 2, but it's only n minus 1 thing. Yes. Okay. So I'll just go over the proof again. So if p divides all values of AI, then just divide all AI things by this, or all the arguments that follow, just replace p with p square or whatever power of p. And because there are more than p minus 1 by 2 numbers, we know that there will either be some I such that p divides AI, or there will be something that p divides AI plus AJ, or there will be something such that p divides AI minus AJ. So in the first case, we note that P divides then AI by GCD of AIAJ. If we can pick a J such that P does not divide, I'll also write this, P does not divide AJ. Yeah. So if this first case is not true, then none of them are 0 mod P. All of them are non-zero. If the third one is false, then all of them are distinct mod P. But if the second one is false, then for every pair x comma minus x, at most one of them can be there. So at most P minus 1 by 2, which is n minus 1 numbers. But we have n numbers. So at least one of these three things is going to be true. So in this case, we have that thing, let's just call that thing equal to S. S equal, so S is greater than AI by GCD of AIAJ. But P divides this, so this thing is at least P. And we're done. In this case, P divides AI plus AJ, but does not P does not divide AI comma AJ.
How does wait. What is S? Oh, that's
S
sum.
is AI plus AJ by GCD AJ. In this case, P will just divide AI plus AJ by GCD AJ, so you're good. And the last case is this. We know that AI plus AJ by, because P divides AI minus AJ, we know that GCD of AI minus AJ, of AI comma AJ, is at most AJ minus AI. Or we could just say AJ minus AI over P, which is clearly greater than P. So since one of these cases must be true, we can find such INJ, such that sum AI plus AJ by GCD IAJ is at least 2n minus 1, which is P. So the only thing that is left is to show the converse, that if 2n minus 1 is composite, then we can find a counterexample, which is interesting. Let's say look at 2n minus 1 equal to 9 when n equals 5. How would we do that? One.
1, 2, 3, 4, 6.
Hmm?
1, 2, 3, 4, 6.
For 9, 1, 2, 3, 4, 6. I see. So you're just ensuring that 6 and 4, 6 and 3 have GCD, so they'll get divided out. Huh. Actually. Thanks.
But this was quite lucky because 6 is not co-prime to 3 or 4.
Mhm. Also, do these numbers have to be distinct? Distinct. Okay. If there's some more generalizable counterexample. Okay, also let's look at 15. And we need 8 numbers in this case. It would be nice if we could just take 1, 2, 3, 4, 5, and then pick 6 is good enough. But then 10 next. And then 8, 6, 8, 10. That looks valid. Yeah. Okay, interesting. So let's say 2n minus 1 can be written as AB. I was thinking if we could do something of the sort like, never mind. How do we generalize this sort of thing? But if we just try 1, 2, all the way till some number, and then we're taking sort of half of them.
It should also depend on the fact that 2n plus 1 is composite. So 2n minus 1. So,
Yeah, that's why I'm trying to use like these factors A and B.
so maybe like 1 to A and then A plus B, A plus 2B, A plus 3B.
Yeah, I was thinking that, but that's just too many numbers. Like if you're trying to do this.
Yeah, yeah. And A plus B is like not even working for 15.
Yeah. Okay, why does this construction work over here? So
We
we
need to show that
ensured
2n
these
minus 2 is like bad, right?
sorry,
Or we need to show 2n is bad, right?
2n,
Oh,
what do
sorry. N minus 1 numbers.
we want n numbers. Like we're trying to find a counter example when 2n minus 1 is a composite.
Oh, fine.
Okay, next attempt for 21. And we need 11 numbers in this case. Mhm.
Or if we just do 8, 10, 12, 14.
Yeah, 12, 14. And this also works out.
How is this like working every time? Like we're doing 5 and then 10.
No, like the point is the real counter, we're picking even numbers here.
Yeah,
So
but
the,
like here it sort of makes sense. No, not really. Okay,
oh,
maybe it's
can you
because of
do this?
multiple of 3. So maybe you want to do like k minus 1.
A minus
Like
1.
B minus 1, sorry. Like 1 to A and then A
But here
plus
we
B
never
minus.
use the fact that 3 divides, no? We just use the fact that 7 divides.
But we're also adding 3 minus 1 each time later on. Maybe
I mean, the 3 minus 1 is not really relevant, no? Like at no point do we have 3 being GCD of 2 numbers.
yeah.
So maybe what if we try and do like 1, 2, all the way till A plus 1, A then A plus 1, and then A plus 3, A plus 5, all the way until 2A. Is that a valid thing? Okay, of course it has to depend on B. Never mind. You're right.
Also what 2A and A plus 1 GCD will be like 1. Okay, but 3A plus 1, yeah, it depends on B.
No, 2A and A plus 1. Wait, A plus 1 is supposed to be even, no? So it will divide by 2. That was the point.
Okay, okay.
These
Yeah.
are all even numbers.
Yeah, yeah, yeah.
Okay, so in general, how many numbers do you want? We want AB plus 1 by 2. And this was giving out like A minus 1 by 2. And
Yeah, actually I think this works, right?
it does. Oh, I see.
Why
You're
not?
right. So we take 1, 2, all the way till A times B minus 1 by 2. let's call this number capital C. Then we take C plus 1, C plus 3, all the way until C plus A. And this is a valid construction. Maybe I'll stop
How do
writing.
we ensure that C is even? Sorry, odd. How do you ensure C is odd?
C is odd because, oh, we can't ensure it, you're right. I think if C is even, just work with C plus 2, C plus 4 and stuff.
Oh, okay. I
Like
see.
you can ensure C is what do you say? Odd, right? Like it cannot be a power of 2 because it's like 2n minus 1 you're dealing with.
I mean, if B is 1 mod 4, you're already dead, no?
Uh, uh, why
Okay,
we are
so
dead? Like you know, you need B to be odd.
sorry,
You need B to be odd, right?
we want C to be odd. A and B are already odd because they divide 2n minus 1.
You need C to be odd. Like,
Yeah.
I don't need C to be odd.
Because the point was, when you add anything among these things, they'll
Oh,
divide
right.
out
These
by
are
2.
even. Yeah, okay.
I feel like, okay, let's assume C is odd for now. Does this work? Actually, I'll not write C because I want to know exactly how much this is. A, B minus 1 by 2. And A times B minus 1 by 2. Does this work? We want any such sum to be at most 2n minus 2, which equals AB minus 1. AB minus
No, but you can take like a plus 1 and ab minus 1 over 2 plus a. No, that does not.
what?
So these numbers are very close to half of 2n minus 1.
Yeah.
Okay, but there should be some two which are adding to 2 and they are co-prime. Because you're taking like almost.
Like I thought the only contradiction would be if you could add this number and this number because you're not dividing by 2. But when you're doing these two, the factor of A comes in. So
Okay.
you have to divide by that.
So
AB, yeah, I think so.
Right, if like A into B minus 1 by 2 is even, then we can just work with plus 2, plus 4, and so on. So
Yeah.
when we add these two, then these two will also have a factor of 2 that will cause their sum divided by these.
Okay, yeah. If it was even, then we don't really have a problem. We could just continue the plus 2 thing. In the odd case, the real problem was because this number and this number, when you added them, they were co-prime. So you got their sum, which was bad. Because it's what? AB minus A. Okay, something of this sort. But yeah, in this case, we avoid that with the factorial thing. So this works. Yeah. Okay, does anyone have any questions? This will be our last problem today because it's past the 8:30 mark.
Can you show the problem? I forgot the problem, I realized.
Congratulations.
Oh yeah, fine. Okay.
Anyone else? Okay, then I guess that's it. Thank you all for attending the class. It was fun.
Thanks for taking the class. Should I stop